Question 8. An isosceles triangle ABC is inscribed in a circle as shown. The circle has a center O and radius 10. Okay, so a radius of 10. So that'd be 10 and that'd be 10. Okay. And CAB, so C to A to B is 2A. So that means each individual one will be A. So that means you're A. You're A. Now it's made up of three equal. Sides. Okay. Now I have an idea. What I'm going to do is I'm going to find out what AM is. Okay, AM first. Alright, now it's a right angle triangle. So that's alpha, that's 10, and the bottom is A to M. We'll just call it X for argument's sake. So cos alpha is X over 10. Then X on its own is 10 cos alpha, and that means AM is 10 cos alpha. That means A to B must be 20 cos alpha because it's twice the distance of A to M. Okay, so hopefully that clears that one up. Alright, let's move on to the next part. Sorry, where's part 2? There it is. Hence show the perimeter of the triangle ABC is equal to 40 cos alpha 1 plus sine alpha. So the perimeter, interesting. Perimeter of ABC. That's the perimeter is the outside one. And it's an isosceles triangle. Alright, so it's an isosceles triangle. So let's focus on the angles here for a second, right? So if it's isosceles and that's 2 alpha, it looks pretty obvious that these two are the same length as each other. AB equals AC, it tells you. So these two are the same length as each other. So we're going to do 180 take away 2A. Alright. And that means that the remaining two angles, the two green angles, have to be the same as 180 minus 2A. Divide that by 2 and you get 90 minus A. So both of these are 90 minus A. Okay, so that's 90 minus alpha. Excuse me. And that's 90 minus alpha as well. Now, I'm going to have to find out what BC is because I already have AB and I already have AC. AB and AC are both 20 cos A. So what we can say is the perimeter is AB plus AC, and then we also have plus BC. And what we currently have is 20 cos A plus 20 cos A. That's good for our temp marks. Now we're going to spend all our energy finding out what B to C is. Okay, now I'm going to stick with the diagram here because I need to find this out. Okay, so it's an in circle. So for me that means it bisects the angle. So I think I was going down. I was thinking about doing it this way as 45 minus alpha over 2, but that looks very complicated. And I'm sure there is a way out of that. But there's another rule that we should think about here. If this is 2 alpha, remember the circle rule. If that's 2 alpha, that means that this angle here that's standing on the same arc. They're standing on the same arc. and this is at the center of the circle, that would mean that that's 4 alpha. Okay, so that's 4 alpha right there. Okay, so if I draw this triangle, what's it, OBC, and I cut it in half, so that's OBC. If I didn't see this, I was going down a really difficult path. It would have been difficult to see it. That's 2 alpha and that's 2 alpha. So the two of them are the same. And then what I can do is I'm going to find out half of BC using right angled formulas. Now know that that's 10. Okay, and I'm after this, for argument's sake, I'm going to call it y. Okay, and what I can say is that sine 2a, so sine is opposite over hypotenuse. Opposite 2a is y, so it's going to be sine 2a equals y over 10, and then y equals 10 sine 2 alpha. Now, okay, now BC therefore is double y. BC is 2y. This implies that BC is 20 sine 2a. Now if you look at your answer, there's no sign of any 2a in your answer. Okay, and because there's no sign of that, you need to go to page 13 or 14 of your tables, and you'll see that sine 2a is the same as 2 sine a cos a, and then when you multiply that out, you're going to get your 40 sine a cos a, and then the 2, obviously the 220 cos alphas also gives you 40 cos alpha. So about take out the 40 cos alpha, and then you're left with your 1 plus sine alpha as shown. Now the good thing about this question is it is a proof question, so just because you can't do this part, it may not necessarily mean you can't do the next part. Show that the maximum perimeter occurs. So this is a differentiation question, okay? So maximum perimeter, so it's 40 cos alpha into 1 plus sine alpha. So when you see the word maximum, you're going to use perimeter, alright? So perimeter in terms of alpha, the first derivative is dp d alpha, alright? Now, if you're a cheating man or a smart person, I'm going to just quickly do this in degrees, alright? So 40 cos alpha, I'll say 40 cos x, and then I'm going to do 1 plus sine x plus sine x, close it. I'm going to start at 0, I'm going to end at 90, and I'm going to go up in steps of 5, alright? Now it's currently in radians, so I need to fix that. Shift, setup, angle unit, degrees, and then press equals again. I might go through the full process again, just to make sure. Alright, so here's what I'm looking at. You're looking for maximum perimeter. So I'm just going to scroll through this until I find the maximum perimeter. Oh, there it was. I think it's somewhere in the 30 degree category. Somewhere in between 30 and somewhere in between 25 to 35, alright? So I'll zone in on that. 25, 35. I have a rough guideline of where I'm expecting my answer to be, which is pretty handy. There it is. And it's symmetrical as well. It's definitely 30. Alright, so I already know my answer, alright, which is great. You could always try the trial and error method and pretend that you're just subbing in like random numbers until you find it for attempt marks if you aren't sure about the differentiation, but realistically you're going to be differentiating this. So u equals, we're using the product rule, which is u times the v dx plus v times du dx, but in this case we're using du d alpha, because u is 40 cos alpha, and cos alpha turns into minus sine alpha, and then v is 1 plus sine alpha, When we differentiate that, the 1 turns to 0 and the sine alpha turns into cos alpha. Okay. Then we're going to put in our numbers now. So u is 40 cos alpha times cos alpha, and then it's going to be plus v, which is 1 plus sine alpha, and then it's going to be times du d alpha, which is minus 40. Is that right? Minus 40. 1 plus sine alpha, du d alpha is minus sine alpha, I'd say. Minus 40 sine alpha. So, yeah, I think we're actually on the correct path here. It's just a complicated path. Yeah. Now, this type of equation, the problem with it is that there's two variables. So I'm looking at cos squared alpha there, and I'm thinking cos squared alpha plus sine squared alpha equals 1. Therefore, cos squared alpha on its own is 1 minus sine squared alpha, right? And to save myself writing another line, I'm just going to change that into 1 minus sine squared alpha. Okay, and I'm going to multiply all this out, and by the looks of it, I might be getting a quadratic out here. So it's 40 minus 40 sine squared alpha. Now please remember, maximum means the slope is 0, so you're going to be talking about all this equal to 0. 40 minus 40 sine squared alpha minus 40 sine alpha minus 40 sine squared alpha. Alright, divide everything by 40. In fact, divide everything by minus 40. And that'll be, what's it, minus 80 sine squared alpha. Divide that by minus 40, and you get 2 sine squared alpha. Divide the minus 40 sine alpha by minus 40, and you get plus sine alpha. And that'll be what's 40 divided by minus 40? It's minus 1. Now, we're going to solve this. You don't need the minus b. This is going to be 2 sine. It's a quadratic equation. It's 2x squared plus x take away 1. It's exactly the same thing, except it's just sine alphas instead. This is grim. That's a plus 1. That's a minus 1. That's all equal to 0. And I suppose what we're getting here is that when we solve this equal to 0, it's going to be 2 sine alpha minus 1 equals 0, and sine alpha equals a half. Sine inverse alpha equals 30 degrees, which is what we're expecting. This one here isn't going to work because it's minus 1, and you can't really have, what's it, 270 degrees. That won't work, so we have the answer we require. Okay, once again, that was awful. That took a lot of effort. Hence, find the maximum perimeter of the triangle in third form. Oof. That's my answer there, 51.94, or sorry, 51.961, but we obviously want to use the equation. So we're using this equation here. 40 cos alpha into 1 plus sine alpha. And we know that alpha is 30 degrees. So it's 40 cos 30 into 1 plus sine 30. And you'd hope that if you throw all that into the calculator, that it will come out quite nicely. 30 root 3. Yeah, we'll take 30 root 3. Now, centimeters. Okay, what's the next thing I'm doing? Show that the area is equal to this. Oh, the area of the triangle. Oh, dearie me. Alright, let's think about this. Alright, we can agree that this triangle here, the black one and the red one, are actually the same area as each other. Right, so that's good to know. Okay, so we know that much. And so we could do base times height. Half base. There's many different ways to go about this one. Yeah, there's so many different ways to do this. It's actually insane. So I could do base times height for all three of them. Another method could be that you see the way you know that that one's 2, what's it, 4a from earlier. So that was 4a. Alright, so then it'd be 360 minus 4a is left over, or 4 alpha, and then these two angles are the same as each other, and I'd have them both down as 180 minus 2 alpha, and then you could do 180 minus 2 alpha, and then, oh, that's a very sneaky way of doing it. See the way they're all radiuses of 10, so I could do a half 10 times 10, the angle in between, because a half AB sine C, right? And that'd be sine 180 minus 2a. Now there is a rule regards to first quadrant, if you ever look at it, is that for example sine 30 is exactly the same value as sine 150. So sine 30 is a half sine 150, also a half sine, I don't know, 10 is the same as sine 170. Once both angles add up to 180, they're equal to each other, right? So then I could, for argument's sake, I could say that sine 180 minus 2a is equal to sine 2a, because when I add both angles together, it's the same. So it's going to be 100, so it's going to be 50 sine 180 minus 2a, and that's the same thing as 50 sine 2a. Right, and that's the area of, that's me getting the area of AOB. Area AOB equals 50 sine 2a, and so does the area of AOC, also equals 50 sine 2a. Now, then that leaves me the bottom triangle, which we all read earlier as, because the top one was 2 alpha, this one's 4 alpha, and once again that's a 10 and a 10 right there. So what I'm thinking here is a half, I think I've gone a completely different way than the book, but I think it's the faster way. Yeah, the book has a different way of doing it. The book does half base by height and does a lot of individual working out. The marking scheme, I mean. But I think I prefer my way. Okay, and that's for the triangle BOC. And that's going to be 50, half of 100 is 50 sine 4 alpha, alright? Now, when we add the three triangles together, I'm just going to blank out the bottom question. Just simply haven't got enough, enough space to work with here. Okay, we add the two of them together and we get 100 sine 2 alpha. Now see the sine 4 alpha business. Now what we learned earlier was that sine 2x equals 2 cos x sine x, or 2 sine x cos x. Okay, that's on page 13 of your tables. And when I'm looking at the answer, I'm seeing that it's all those single angles. There's no double or quadruple angles. Okay, so I'm going to change everything. So see the sine 4 alpha, I'm going to change that into 52 sine 2 alpha cos 2 alpha. Alright. Interesting. Hoping I didn't dig myself into a hole here. So that would be 100 sine 2 alpha cos 2 alpha. Alright. Now the two of these are going to add together. Once again, it's so difficult. Like it's I haven't dug myself into a hole, but it's very hard to know where you're going from here. You just keep going, essentially. So what you're thinking is actually a handy trick that some of you might not know is you can actually use an angle to verify your answers, right? To see if you're on the correct path or not, if you've made a mistake. So if I did, for example, 400, and I'll pick any angle, like let's say I pick 10, alright? And I'll just choose cos 10 to the power of 3. I'm basically just testing now what an angle of 10 would give me as an answer. Sine 10. I go, no bother. Oh, that gives me 66.34. Alright? And then I go down here and I do exactly the same thing. I'm choosing to use an angle of 10, so it's going to be 100 sine 20, and then plus 100. If both of these equal each other, it means I still haven't made a mistake, and it's just a matter of me. Yeah, they're both exactly the same, which means I haven't made a mistake. I just need to make my answer look like their answer, and that's very reassuring to know. So I'm going to factorize out 100 sine 2 alpha, and what I'm going to get is 1 plus cos 2 alpha. Now I know, once again, I'm not allowed any double numbers, so I'm going to do exactly what I did earlier. 100 into 2 sine alpha cos alpha, I believe. 2 sine alpha cos alpha. Now see the cos 2a. Alright, so cos 2a, I want to get rid of that 1. Alright, so there is a way of doing that in your tables. I better show you your tables to make this work. So here I am, and do you see this formula here on page 14? Alright, looks very similar to what I have. Okay, and in a way you're meant to know this one as well. So there's a lot of trigonometry revision in this. It's not a great question. It has so much in it. So if I isolate the 1 plus cos 2a, multiply up to 2, so I just get 2 cos squared alpha. Alright? So 1 plus cos 2a is the same as 2 cos squared alpha. I just log in that that's 2 cos squared alpha. Now when I multiply this out once and for all, it's going to be 200 multiplied by 2, which is 400. Cos alpha multiplied by cos squared alpha is cos cubed alpha, and there's your sine alpha. And man, that was difficult. Like, no doubt about it, that was very difficult. Okay, let's see what else there is here. Now, interesting thing here is find the value of alpha for which the area of triangle ABC is maximum. Hence find the maximum area in third form. So once again, we have our formula, and you didn't need to be able to do the last part to do this, because once again it was a proved question. So area okay, now we're going to differentiate it. there's the u. It's once again, it's the product rule. Okay, so u is 400 cos cubed alpha. Now once again, you can do a little trick like I did earlier. You can predict where your maximum should occur. So your maximum should occur at so 400 cos x to the power 3, and then sine x, so sine alpha x, close, close. Okay, start off at 0, go up to 90 like last time, go on a step of 5. Let's track the area. So no angle equals no area. An angle of 15 degrees gives you an area of 93. Keep going until you reach your maximum area. Maximum area seems to be at 30 degrees again. Okay, so what we'll do here is I will zone in on the 30 region. So we go 25 to 35, step of 1. Alright, you're just sort of zoning in, and you just keep scrolling down until you reach your maximum, and lo and behold, it was 30 degrees again. So we're going to go dA d alpha. Okay, now u is 400 cos cubed a, so du d alpha, it's a chain rule because it's basically if I run out of space here, it's 400 cos alpha to the power 3. Now the 3 goes to the front to make 1200. You take 1 away from the power, and that leaves you cos squared alpha. You then differentiate cos alpha, what's in there, and it turns into minus sine alpha. And then you've got minus 1200 cos squared alpha sine alpha. Okay, and that's how you du d alpha. Now, that leads me on to v. V is sine A, and then dv dA is sine A changes into cos A. Now, please remember, when you're doing differentiation, please look up your notes when you're doing it. You do not want to get mixed up between integration and differentiation, and you always want to double check using your maths tables. Okay, now we're going to do u times u times dv dA. Okay, so that is u times dv dA plus v is sine A, times du dA, which is minus 1200 cos squared alpha sine alpha. Alright, so what we're looking at, and remember, it's about maximums, isn't it? So that's cos 4 alpha, and that's minus 1200. What's it? Cos squared alpha sine squared alpha. Now, too many variables here. I'd like to change everything just into causes. So see that sine squared alpha? What I'm taking is sine squared alpha plus cos squared alpha equals 1. Sine squared alpha on its own is the same as 1 minus cos squared alpha. Okay, so I'm going to change that into 1 minus cos squared alpha. Once again, I'm just saving myself time. It's a lot of work. Now, multiply that out and we get 400 cos 4 alpha minus 1200 cos squared alpha, and then plus 1002. Oh, sorry. I was isolating sine squared alpha, and that should be cos squared alpha. Okay, so plus 1200 cos 4 alpha. Alright, I think we're in business now, because it's basically the equivalent of 800, is that right? 800 cos 4 alpha minus 1200. Yeah, we're in business. For those of you that don't know, I'm essentially doing this equation here. I'm doing 8x to the power of 4 minus 12x squared equal to 0. I'm going to take out, what am I going to take out? I'm going to take out 4x squared, and I'm going to be left with 2x squared minus 3 equals to 0, right? So that's essentially what we're doing here. Because when we divide by 100, that's what we have. And then I'm going to take out 4 cos squared alpha, and that's going to leave me 2 cos squared alpha minus, what's it, 3. And we don't want it to be equal to 0, so this is the part that I'm interested in. This is the part that's going to get me the 30 that I was looking for. So 2 cos squared alpha minus 3 equals 0. Bring over the 3. 2 cos squared alpha equals 3 cos squared. Actually, lads, whoop, thank God I actually spotted a mistake, but thank God thank God I knew about the it's actually 16. It's 1600, not so that's 1600. That's makes, when I take out 4, that makes that also 4. It was 1600 up here. It was actually addition, not subtraction. But that's the great thing about knowing your answer. You know that what you're expecting. And I'll tell you how I knew I made a mistake in a second. Cos squared alpha equals 3 over 4. I need to square root both sides. I knew that cos alpha was I knew cos alpha is root 3 over 2, because I know it's 30 degrees when you inverse it. So I knew I needed a 4 on the bottom. So when I square root the top and the bottom, the square root of 3 over 4 is the same as root 3 over root 4, which is root 3 over 2. And then you cos inverse that, shift cos inverse. And lo and behold, there's your 30 degrees, as predicted. And thank God I am done with that question, and I shall hopefully be on to question 9 soon enough. The end. 33 minutes that took.